Okay, everyone, so today we're going to do something a little bit different. We're going to take the first lesson in Unit 6, which is adding and subtracting polynomials, and go over it with you in a flipped video. So right now you should have your Unit 6 packet out in front of you, which you should have picked up after completing the second part of your Unit 5 exam today. I'd like you to open up to the first page, which has a Do Now, that says adding and subtracting polynomials. The way this is going to work is we're going to go over this lesson in the video because a lot of the topics in this lesson are review from prior years that you've studied polynomials in math. So for right now, what I would like you to do is pause the video. There are 5 questions on the Do Now. I'd like you to complete them in your packet. Then replay the video and we'll go over them together and you can check over your work. So pause the video and complete the 5 questions. Okay, so now that you've taken some time to try the 5 questions, we'd like to go over them with you. So, question 1 asks us which word describes the polynomial. So, at this point, we're assuming you remember that a polynomial is an expression of terms. So the amount of terms can also be described as a specific type of polynomial. So in this expression, we have one term, 3x squared, we have another term, 4x, and we have a third term of 2. Polynomial is the umbrella term that describes an expression of terms. However, if I know the amount of terms in the polynomial, again, I can use a more specific name for certain types of polynomials. A monomial would be if there was one term. So that's not the case here. A binomial would be 2 terms. Again, not the case. A trinomial is a polynomial with 3 terms. So choice 3 does accurately describe that polynomial. Number 2 asks us the degree of the polynomial. So the degree of the polynomial is always going to be based on its highest exponent. So if I look at this polynomial, my first term here has x to the 4th. Well, as long as that was my highest exponent, that would describe the degree. But as I look down, my second term is a to the 5th. So if I'm raising a, excuse me, I said x before, a to the 5th power, 5 is a higher power than 4. And as I look down at the rest of my expression, I have a to the 1st, and 12 does not even have an a. So my highest exponent is a 5. So that means this polynomial is to the 5th degree. Question 2 asks you to circle the leading coefficient. Well, when a polynomial, when you've identified its highest power, that term should be the leading term. And coefficient is the number in front of your term, that numerical term in front of your variable. So when I look at this polynomial, I see 4x, which is raised to the 1st, negative 3x squared is raised to the 2nd, and 5 does not have an x. So negative 3x squared is what is raised to the highest power. That should be my leading term. So when I look at this term, it's the negative 3 that would be considered the leading coefficient because it's in front of the leading term. Question 4 asks us to circle the constant term of the polynomial. Constant term is the term that does not have a variable. So as I look down this polynomial, I have an x in the first term, an x squared in the second term. 5 does not have an x, so 5 is my constant term. It will remain constant no matter what, since it is not associated with a variable. And the last question says to circle the choice that represents the following polynomial in standard form. Now, standard form kind of brings everything we've just been talking about together. When you have a polynomial in standard form, it means your highest exponent term is first, and then your exponents will go in descending order until your constant term. So I'm going to look at this polynomial, and I'm going to rewrite it in standard form. 4x to the 3rd has my highest exponent, so that term should go first. Negative 7x squared is the next highest exponent, so that's going to go second. Then I have 6x to the first. Remember, if I don't see an exponent written, I know that it's raised to the first power. And then that negative 2 is my constant term. There is no x. The constant term should always go last in standard form. So if I take a look at my choices, choice 4 is the only one that accurately represents a standard form polynomial. Since this is in a video, I would like you to now go back and re-watch these 5 questions if you got any of them wrong or if you want to go over one of those topics again. Now that we've reviewed some of the terms that we need to understand when talking about polynomials, now I'd like to try a few examples where we're going to add and subtract polynomial expressions. So we're going to move on to number 1 in your packet. We're given one polynomial as a. So they tell us that a is equal to 7x cubed minus 3x squared minus 6x plus 2. And b is equal to 2x cubed plus 4x squared minus 5x minus 9. And what they want us to do is find what a minus b is. So if I want to take a and subtract b from it, I have to remember that a was this polynomial, 7x cubed minus 3x squared minus 6x plus 2. And what we're going to always do here is when we plug a polynomial expression in for something, we're going to put it in parentheses. So there's my a, and now I'm going to subtract b. I'm also going to put b into parentheses and write out what b is. So 2x cubed plus 4x squared minus 5x minus 9. Forgot my x there, minus 5x minus 9. Okay, since we are subtracting is going to change the sign of everything to the right of it, since this minus sign is really going to need to be distributed to my b polynomial. Whereas my leading polynomial, my a, has a parenthesis around it, but the only thing in front of a is really just a positive 1. So what I'm going to do is I'm going to drop the parentheses on my first polynomial, and if you didn't write parentheses around this one at all, that would be okay. But if you didn't write parentheses around your b polynomial, the one that we are subtracting from a, you would only be subtracting the first term, which would then lead you to the wrong answer. You have to put parentheses around an expression if that expression is more than one term and you are subtracting. Because now what's going to happen is my positive 2x to the third is going to become a negative 2x to the third. My positive 4x squared is going to become a negative 4x squared. My negative 5x is going to become a positive 5x. And my negative 9 is going to become a positive 9. Every single term in that polynomial should have changed its sign. Now I'm going to combine like terms. Like terms mean that they have the same variable and the same exponent. So 7x to the third is going to have a like term with a negative 2x to the third. Negative 3x to the second is going to have a like term with negative 4x to the second. Negative 6x has a like term with positive 5x. And last but not least, our constant terms, positive 2, has a like term with our constant term of positive 9. So when I go to rewrite this expression in simplest standard form, what I really want to do here is make sure all my like terms are combined and that my expression has the highest exponent first and goes in descending order. So 7x to the third minus 2x to the third. 7 minus 2 gives me 5. X to the thirds. Negative 3x to the second minus 4x to the second. What I'm doing there is taking negative 3 and combining it with a negative 4 to give me negative 7x to the second. Then I have negative 6x and positive 5x. Negative 6 plus 5 is negative 1x. Positive 2 plus 9 would give me positive 11. Now the only thing here is if you didn't want to write that coefficient of 1, you don't have to, but if you did write it, that's okay. So either version of this answer, whether you put the negative 1 or you just put the minus sign, are correct. These are both in standard form. Example 2 asks us to subtract 5x squared minus 7x minus 6 from 9x squared plus 3x minus 4. So if I'm subtracting one expression from the other, the expression that comes second is really the one I'm going to write first, since I'm subtracting the 5x squared polynomial expression from the 9x squared. So I'm subtracting the first one from the second. Again, not forgetting my parentheses so that I don't forget to distribute that minus sign. At this point, if you would like to pause the video and try the question yourself and then unpause it and check your answer, please do so. My parentheses do not need to be around my first expression since there is nothing being distributed to it other than a positive 1. My second expression, I do have to distribute that minus sign. So the positive 5x squared becomes a negative, the negative 7x becomes a positive, and the negative 6 becomes a positive 6. Now again, I'm going to think about my like terms. So 9x squared is going to have a like term with negative 5x squared. Positive 3x has a like term with positive 7x. And my constant term, negative 4, has a like term with positive 6. If I combine now these like terms, 9x squared minus 5x squared, 9 minus 5 is 4x squared. 3x plus 7x, 3 plus 7 is 10 with that x term. And negative 4 and positive 6 added together give me positive 2. So 4x squared plus 10x plus 2 is the difference in standard form of those two polynomials. The last question we're going to do together is example 3. A company is producing X units of product per month. They tell us that C of X represents total cost. So let's just underline some things. X is the units of the product per month. C of X represents total cost. R of X represents total revenue. The functions are modeled by, here's my C of X function. Here's my R of X function. They tell me the profit is the difference between revenue and cost. So if P of X is my profit, P of X can always be found, or profit can always be found by taking your revenue, which is what you earn, and subtracting your costs. So, for example, if you were to sell holiday mugs, and it cost you $2 to buy the materials to make the mug, and you sold them for $10, your revenue is your $10, but you spent $2 to make them, so your profit would be $8. So profit is your revenue, what you earn, minus the cost that it takes you to make, is equal to your profit. So they want us to find the total profit here, meaning if we take P of X, we want to find that when we know it's equal to R of X minus C of X. Well, they told us here what R of X and P of X and C of X are. R of X is X squared plus 480X minus 82. I got that right from here. And I'm subtracting C of X, which they told me here is 250X plus 100. So this really is just the same kind of question that we did in question 1 and 2. It just had a little bit more of a wordy word problem nature to it. So we had to really read through it before we could turn this into just a subtraction problem. So again, my first polynomial expression R of X does not really need the parentheses around it since it has a positive 1 in front. So I'm just going to rewrite that as X squared plus 480X minus 82. However, my cost expression, C of X, is being subtracted, so I need to distribute that negative. So minus 250X minus 100 took both of those positive numbers and turned them into negative numbers. Now I'm going to combine like terms. When I look at my X squared term, I notice that that's the only X squared term, so it doesn't have any like terms. So in my answer, X squared is just going to stay X squared. But let's keep looking. Now we have positive 480x and a negative 250x, so that does have a like term to combine with. And again, our constant terms in this case are negative 82 and negative 100. So when I go to write this out, if I have 480 and I subtract 250 from it, I should have 230x. A negative 82 and a negative 100 would give me negative 182 as my constant. So my profit function is best represented in simplest form as x squared plus 230x minus 182. Okay, at this point in the lesson now, we would like you to practice. So the way we set up the practice for this flip video was to make it a QR code practice so that you could have the answers with you just by scanning a QR code using your phone. So if you don't have a QR code scanner on your phone, it is a free app. I think most phones have the ability to get it very quickly and free. So if you don't have one, pause the video right now, download a QR scanner, and then continue watching the video. So the way the practice is going to work, you have 3 more sheets in your packet, examples 1, 2, and 3, that look like this. The steps are as follows. List your terms in descending order, so standard form. So the first thing you're going to do for each example is look at your A and B, because each example is set up as an A and a B polynomial, and write them in standard form before you ever go into the boxes. So for each of these, you would just rewrite them standard form. Then step 2, group your like terms together. Okay, well, now that they're in standard form, now I'm going to start looking down here. Now I'm going to rewrite my A in standard form and add it to B and combine like terms. Then I'm going to go to A minus B. I'm going to rewrite my A in standard form, subtract B from it in standard form, and combine like terms. Don't forget to distribute your minus sign. Don't forget your parentheses. Then I'm going to do a third example with these 2 polynomials. I'm going to take B and subtract A from it, again, not forgetting parentheses and not forgetting to rewrite things in standard form. Once you've completed all 3 examples using the 2 polynomials in that question, then you're going to go to the bottom and you're going to scan these QR codes to check to see if your answer is correct. So since there are 3 examples like this, you're really doing 9 questions. In each example, you're going to add the 2 polynomials, subtract them twice in both order to show that really in subtraction, order matters, because you should get a different answer depending on what direction you are subtracting. Okay, so we hope that you take some time to practice, you check things over. You do have a homework tonight, so even though it's the night of a test, because we're doing a flip video, we do expect you to come in tomorrow having tried homework 6-1 in your packet. Try that homework, come in tomorrow. We will go over some things from this lesson and start lesson 2. Thank you so much.